So yeah, let's get the camera rolling there.
It's rolling.
So today we are talking about binomial distribution. So it's probably going to be a two-part. The first part is going to start off quite easy. The second part will also be quite easy. We're going to look at two different ways of basically doing the same thing. So here we're talking about discrete options, and we're going to use this formula here to answer some questions. And I think if we get into it, and then we can sort of explain what the formula means in the context of the question. So we've got a big amount of text there. Let's jump down to this part here where it says the probability that an apple is rotten. Okay, so the probability that an apple is rotten is 0.35. All right, that's the probability of it being rotten. Given that there's 8 apples in a bag, determine the probability that exactly 3 are rotten. Okay, so with a binomial distribution, all right, there's one property it needs to satisfy, and that is that there's 2 outcomes, okay? They're sort of mutually exclusive. We can grab an apple, it's either going to be rotten or it's not rotten. So we've got 2 outcomes. We have the probability of it being rotten, and then the probability of it not being rotten, okay? So if we have the probability of it being rotten is 0.35, then the probability of it not being rotten, that is being fresh, is 0.65. Okay, but the sum of probabilities adds to 1. So we're asked, find the probability that exactly 3 apples are rotten. So that's where we're talking about, okay, our number out of 8 apples. We've got 8 apples, and we're going to have 3 that are rotten. Okay, the probability of it being rotten is 0.35, and the probability of it being not rotten is 0.65. So you might think up there, how come I've defined an apple as being rotten as a success? All right, so it sort of might be, that's not very successful for an apple. So just in terms of the context of the question, we're asked what's the probability that exactly 3 are rotten, and so then we're defining an apple as being rotten as a success. Okay, so that's just what we've said by definition. We've got all the information we need to put it in the formula. The probability of 3 apples being rotten is okay, and that's what we're going to put into our calculator. So we just need a times in there and a times in there. And remember, when we put C into our calculator, okay, here's the instructions on how we bring it up. We get option, prob, NCR, and what we do is, the way we put it in our calculator is we would put 8C3, all right, times 0.35 to the power of 3, times 0.65 to the power of 5, okay? So let's explain that. So let's just everyone have a quick glance up here and I'll explain where I've generated these numbers from. All right, 8 trials, 3 successes, probability of success to the number of successes. Okay, if we've got 3 apples being rotten, and then we've got probability of a failure to the number of failures. If we've got 3 rotten, that means we've got 5 that are right. Okay, notice how they add up to 8. All right, and we're ready to put it in our calculator. So let's do that quickly. 3 out of 8.35, and I've got 0.2785, 279.
I can't find the calculator.
So did you? I might come and help you in a moment, but yeah, option, prob,
Is that in statistics?
no, just in the main menu. Okay, in the next part, we're asked what's the probability that exactly 6 are not rotten, okay? Exactly 6 are not rotten. So there's 2 ways we could work this out. We could say, well, if 6 are not rotten, that means there are 2 that are rotten. So we could perform this calculation with the probability of it being equal to 2, right? We're saying if there are 6 that are right and they're ready to go, it means there are 2 that are rotten. And so that would be this calculation, wouldn't it? Okay, so we could calculate it that way. The other thing you could do is define a success as it being right. All right. So I might keep it like this, just so we're not getting confused. We've got 8c2 times 0.35 squared. So out of that, 2. And I've got 0.2586. Excellent. Okay, so that, what we're going to do, we're going to use that formula to answer these two questions here. All right, and then we'll come back together and we'll look at another procedure we can use for our calculator. So let's give that a crack.